Welcome everybody to today's community meeting. If you're in the US, hope you had a nice long weekend. Otherwise, I hope you just had a great weekend. As always, if you'd like to sign in, please feel free to add your name to the agenda. We'll go through a quick project round robin. We have a lot of announcements this week. We had a few blog posts and a few changes to our infrastructure. And then we also have a demo by Mihai, who will be discussing some work going on in the intersection of AI and Sigstore around model signing, which I'm very, very excited to see. All right, so to kick things off, a couple announcements. We had a blog post go out for Cosign on how to verify bundles from a few different sources with Cosign. This was a new feature that was added in 2.4. So check out this blog post. It talks about how to use Cosign to verify NPM provenance, GitHub artifact attestations, and homebrew provenance using the new release of Cosign. And I'll also mention that Cosign is also able to now produce these bundles in certain cases, and we're working on continuing to make it easier and easier to generate and verify bundles within Cosign. The other major announcement that we had this week is that Sigstore Java had a major 1.0 release. So huge congrats to the folks working on Sigstore Java and some of the related tooling as well around the Maven and Gradle plugins, as well as the folks at Sonatype who helped to add support for Sigstore bundles within Maven Central. So please do take a look at this post. It'll walk you through the work that's been ongoing. Again, huge congrats to everybody for this major milestone for Sigstore Java. Continuing with all of the exciting announcements, and this one is late breaking news, which happened in the last half hour. I mentioned 2 weeks ago that we were going to migrate our production infrastructure, the tooling that helps release our Tough-Root over to a framework called Tough on CI. We just completed this migration over the weekend. We had a release to our pre-production environment, which lets us test against all of the clients. And then we just a half an hour ago pushed out an updated V10 Tough-Root, which has a few changes. Again, this should always be invisible to clients if done right. And one of the major improvements with Tough on CI is a lot more testing before it gets out to production. So hopefully there will be no surprises. The only thing to mention, which we have made the maintainers aware of, is there was a breaking change to the Rust client. Given that the Rust client is not yet in beta, we were okay with this change. The maintainers were notified a bit ago. If you do use Sigstore Rust, this is just a heads up that there's some changes that are going to need to be done in order to support this. But this rollout to prod went very, very smoothly. Very excited to see this happen. For maintainers of any Tough repositories, I would very much recommend checking out Tough on CI. It's a great framework. It very much simplified our signing process for production. It went so much smoother than it has in the past. So huge congrats to that team there on landing that. And then the last thing to mention, we had mentioned this 2 weeks ago that we were going to be doing a database migration. Right now, the plan is for this weekend on Sunday, happening sometime in the afternoon in the EST time zone. So keep an eye on the status page. We'll make updates there as that happens. But there'll be a brief window in which there'll be some downtime. This would impact signing and should not impact verification if verification is being done with offline verification material, which is the default for most clients. All right, I think that was it for good news. And I'll just check as William's joining. William, did you have any other updates? We were just going through client updates and many good news and updates. So I was wondering if you had anything as well. All right, we'll come back. We can move on to docs then. Haley, did you want to give an update?
Sure. So my name's Haley Dunbraver, and I wanted to join the call today just to say hi to the Sigstore community and to let you guys know about some docs modernization efforts that I've been undertaking. The first little bit of that has been I'm working to bring the language client information into the main documentation. And as a first step, we've done some reorganization of the cosign documentation. So there's a current PR open for that. But this modernization effort is a semi-long-term project. So you'll see updates from me throughout the next several months. And yeah, feel free to check out the PR if you're interested.
Thanks for the update, Haley. These are very exciting and much needed changes to our docs. So happy these are coming through.
I think everything is working now. Sorry about that.
Perfect. I just want to check, William, we were just going through updates if you had anything from the client side as well.
Yeah, it's not directly related to the Sigstore Python client. However, I do have a big update on its use within the Python ecosystem, which is hopefully by the end of this week, we will fully merge PEP 740 within PyPI, which means that PyPI will receive and the default uploading client for GitHub Actions will produce digital attestations that are built on top of Sigstore bundles. So when we flip the default on this, I think about 15,000 projects will start signing by default. And those 15,000 are I think by downloads, the top 80% of downloads in the Python packaging ecosystem. So it'll have a huge impact on like the, critical is a dangerous phrase, but the most widely used packages within the ecosystem. So I'll have more to say about that publicly once we actually merge everything, but should be live very, very soon.
You say 15,000?
15,000 currently, yeah.
Wow.
Here, I have a dashboard that shows the current number of trusted publishers. 1 second.
We will be letting on-call know to be prepared for an uptick in traffic, but this is very good traffic.
Yeah, we did the numbers, and it really shouldn't be too much. And I thought it was going to be way, way higher in terms of individual signing events, but it should be only a few thousand more a day. So, but currently 16,000-ish trusted publishers registered, and this is over the past year. So over the next year, we should expect about another 350,000 signing events, so about 1,000 a day. Yeah,
that's amazing. Well, that is a fantastic update. This is the week of updates for ecosystems. So awesome work on this. This is really, really exciting to see. Tracy, did you want to give an update around the client spec?
Yeah, and first let's start out with thanks Haley for those updates. Excited to see that doc modernization happening. The client spec was some work which was living in a Google Doc that's now been migrated over into Markdown. There's a lot of work ongoing to this document, so there's an umbrella issue to track some of the open issues, especially as people are actually using the client spec to implement clients, which is great. So yeah, please take a look at some of the issues. PRs are welcome. And then the next PR for spec docs will be coming up shortly.
Awesome. Thanks so much, Tracy, for the update. All righty. On to a demo. Mihai, if you want to take on over sharing your screen.
Thank you. Yes, 1 second. Share. I will start with just a little bit of slides for context, and then I'll go to the demo. So basically, this is the salsa diagram, but for ML. When we start training a model, it's a little bit more complicated than the salsa diagram, where you just have source code, you build and you deploy to production, and then you put it into an application. For ML, we actually have 2 different cycles. One is for data sets. As you clean the data, you have separate processes in there. And then you combine data sets with different models that you pre-trained before and with the model source ML frameworks. And that's how you train the new model, which you put into production. And which you deploy to a model hub. And then from the model hub, you either take it back to a pre-trained models to continue training later, or you take a model and declare it as a production model, and deploy it into an application, and then it gets used by an application that is XML. And like in the traditional software, there are risks everywhere, and we are trying to prevent them in the AI working group under OpenSSF. For this demo, for model signing, we are trying to protect the model from the moment it gets trained all the way until it gets to the application, so going into production, or all the way until it goes into the pre-trained loop and goes into the next phase of training. And in order to do that, basically, we need to sign the model and verify the integrity at use time or when it gets deployed to the model hub. And then in the model hub, we can display a verified badge that will show like the model hub, like Kaggle, verify that this model has been signed and the signature is valid. Okay, so what is hard about model signing? In general, you think about signing is like hash the blob and then sign the hash, and that's done. Well, for models, they are very large. In general, large language models are gigabytes to even terabytes of data. And this means that when you try to hash them, you are at the limit of the disk performance. So if you have a slower disk, the hashing performance will be very, very slow. If you have powerful disk, it will be a little bit better, but still not efficient enough. And this also raises the issue that sometimes you first train the model, you save it to disk, and then you hash it. So you do double I/O operations. And we are trying to have in the library a possibility to hash the model as it gets written to disk as part of the training process. There is a little bit more complication because training is distributed. So now you have distributed hosts writing to the same bucket where you save the model, to the same location on disk. And you have to make sure that the digest that you built for the model is in a canonical form. And another problem that is on the size area is that because training is expensive and a very iterative process, you keep saving a lot of checkpoints during the training. And you might restart training from another checkpoint, or much later at the end of the training, you might say, instead of picking the last checkpoint and converting that to a model, I might take one of the previous checkpoints and using that as the model. So we never know exactly which of the checkpoints becomes the model that gets used later into production. The other issue about the checkpoints is that during training, we only save 5 of them, maybe 10. And each time we want to save the next one, we delete the oldest one. So we don't want to spend a lot of time signing every checkpoint. We would prefer to only sign the checkpoints that are visible at the end of the job. On the usage part of why signing models is harder than signing a traditional binary blob, sometimes after the model gets trained, we modify the model on disk. We might add a license file, we might add a model card file, we might even train a model for different frameworks. So for, let's say, TensorFlow and PyTorch, we train it for one of the frameworks, and then we convert that model into the format that the other framework uses. So from the trainer point of view, you have an expensive training process that results in a model, and then you have a very short process that converts one file from one file format to another one. And we would prefer the signature to cover everything at once because it's the same producer. But from the user point of view, the user would only want to verify the signature or the integrity of the files that are relevant for the framework that they use. So a user that uses the model with PyTorch would prefer to verify the integrity of only the PyTorch files and not care about anything else. And of course, because we have distributed training, we also have distributed inference, where we would like for very large models that are used by multiple hosts at the same time, we would prefer every host to verify the integrity of only the parts of the model that host is looking at, instead of having a single central host that spends a large amount of time verifying the integrity of the entirety of the model, and then you start the distributed inference process. So how did you solve this in the Sigstore model transparency library? We have several layers. We basically build on 3 layers. The bottom layer is the hashing layer, where we just hash a single object like a file or a tensor. Then we have the serialization layer, where we take a model and we build a manifest for it. And then finally, signing is exactly what Sigstore is doing. Take the manifest and generate a signature for that. And this is where I'll switch to the demo. 1 second to find that tab. this one. Okay, so I downloaded the model from Hugging Face, birth base uncased, and I removed the .git directory because that one is never generated as part of the training. So this is to skip over all of the training parts where we're spending a lot of time just training the model. So right now I have a model that is 3 GB on disk, and we can sign it to the library. The library that we're talking about at the model transparency builds on top of Sigstore Python. So it's using stuff that we already know. And as I said, we have 3 layers. The first layer is the hashing layer, where in this case, I'm just computing the hash SHA-256 of every file in the model. Then the serialization layer would take the path to the model and will serialize it to a manifest. I will show the manifest after the signing. This is the part that takes the largest amount of time because this needs to actually look at all of the 3 GB of the model. In our case, it should take around 16 to 20 seconds. And then after this layer finishes, the next one is the signing layer, 16 seconds. In the signing layer, we convert the manifest to an in-toto payload, and then we sign that with the Sigstore Python library. And it's exactly the Sigstore flow, so I'll go do an OIDC connect on that. So let's do the Google one. And I'll paste it here, and now I should have a signature signed. And of course, at this time, we can inspect the signature is a Sigstore bundle format with the inclusion proof in it, with the payload, DC envelope, and the payload. And if you look at the payload, this is where you can see the manifest. So the manifest is basically because we have used the serialization, we have used the hashing layer to hash every file. The serialization is every file with its own digest. So we have the license for the model with its own digest. We have a config JSON for the model with its own digest. We have several files for Apple Core ML with their own digest. We have the model in the ONNX format for mobile applications. We also have it in safe tensors, so a format that doesn't use pickles. So now let's say a user wants to use this model. They don't need to verify the integrity of the entire 3 GB of the blob. They would only need to look at this manifest for the file format that they are using. So for example, if they are using PyTorch, this is the only file where they need to verify the integrity. They don't care about anything else. However, a model hub, when the model gets uploaded there for integrity, they'll need to verify the integrity of everything. And I also have a demo for the verification, which is basically run the Sigstore verifier on the model. This will create another manifest, which then we check with what is serialized on disk, what comes at the model hub. And then what I have else in the notebook, I can alter the model. So put an attacker hat and remove one file. And now this time when I want to verify the signature, that one should fail because I deleted the file from the model. So now the manifest will no longer match. And finally, as the last demo, we can also check how long it would have taken to build a full blob of the model. And then basically compute that just the digest of the model. In total, this should take a little bit longer. So when we serialize the model with the library, it was like 16 seconds or 11 seconds in this case at the end. When we compute the blob with SHA-256 and compute all of the digest, basically the dir hash, this should take around 24 to 30 seconds, so half a minute. So we have some performance improvements in the library. And just to go more, so this was 24 seconds. Just to go more into what the library supports, there is another way we can serialize the model. Instead of hashing every file individually, we can hash the files by shard. So every 1 GB part of the file would be its own shard. And let's say instead of using SHA-256 for hashing, you are using Blake2. So this is the hashing layer. Then the serializer doesn't change much. The only thing that changes is I'm saying that now I want to serialize by a file shard, and I want to use the sharded hasher factory. And this one would be also like 10 to 16 seconds. So again, the needs to look over all of the 3 GB of the model. And now once this finishes, I can sign the model and then I can look at the signature. And this time I'll do the same OIDC flow. And this time when we look at the signature, we will see that every shard of the file would show up individually. So for example, for this weights binary on CoreML, I have one shard from this offset to this offset, and then the next offset continues after that, and so on, or like the PyTorch hashes are here. And this would be all on the demo. I put the link for everything in the document, in the meeting notes.
That's a fantastic demo. Thank you for sharing that. I guess I'll throw it open to anyone else who has questions as well. But I guess maybe one question to get us started. What's next for the project? What are the next big things that you're planning to tackle?
Sorry,
you're
I was
muted.
muted. Yeah, one thing is we need to create a higher level API to make it easier for users to use. So right now you saw to compute the signature of a model, I had to run 3 different cells in the notebook for each layer. We would want to have an API that you just specify which layer you have pre-built blocks, and you specify in the API which blocks you want to combine. And this way, when we integrate this with libraries or with model hubs, it will be much easier for them to specify this is a small model, I want to hash it in this way. This is a very huge model, I want to hash it in this separate way. And instead of having to write a large amount of code for each scenario. And I already hinted that we want to integrate with model hubs, so TensorFlow, PyTorch, and so on, such that when you train the model, as soon as the training finishes, you have the model and the signature at the same place. And with model hubs for verification or for signing, as soon as you upload the model there, you can do verification or signing depending on if the model has been already signed or not.
Awesome. I guess maybe one other question. Do you have some criteria for when to select different sharding strategies?
We have to run benchmarks for this. So that's another part of the development process. So right now the library is still in alpha until we finish running benchmarking and have more documentation and so on, more guides. We want to move past alpha. So yeah.
Awesome. Any other questions? Thanks so much for the demo, Mihai.
Thank you.
Awesome work. Alrighty. Before we move on to outreach and events, any other project updates anyone wanted to give? All right. Well, I'm jumping right into it. We talked about this last week, but I wanted to give another shout out this week to SigStoreCon. One update is that we do have now a venue for it, which will be the Hilton Salt Lake City Center, which is quite near the KubeCon conference center. The one deadline to mention is the CFP is going to close in a week and a half. If we need to, we can extend that, but ideally we'll be able to hit this deadline, as that'll give us enough time to do reviews and get notifications out to authors. If you'd like to submit a proposal, please go to this link, follow submit a proposal, find a track that fits. I'll also mention that we are inviting talks from more than just Sigstore, but what we rely on for Sigstore, things like Tough or Transparency, along with applications that are using Sigstore, Salsa, OpenVex, SBOM. I know we already have a couple CFPs that have been submitted, so if you're on this call and you have, thank you very much. But if you have any questions, shoot me a message or feel free to post it on our Slack channel. And as for registration, it is excuse me, it's a $50 fee. This will include swag, lunch, and some coffee. We are working on getting integrated into the KubeCon registration flow as well. So when you sign up for KubeCon, you'd be able to sign up for SigStoreCon as well. But for now, you can follow this link to sign up within our own registration flow. Tracy, did you want to give an update for Transparency?
Yeah. I think I want to highlight this again, Transparency Dev Summit, which is coming up October 9th to 11th, hosted by Google at their London offices. So the intention of this event is to bring together the various transparency communities, so certificate transparency, binary, including Sigstore, and I think maybe even a few from key transparency folks. And the idea is to just do some cross-ecosystem seeding and collaboration, as well as just a focus on like log operators and how to make it easier to run logs. So specifically for Sigstore, we will be having some talks there and a dedicated breakout session. It's sort of under the umbrella of binary transparency, but I think that will be Sigstore ++. And there's also plans to have a witnessing breakout session to kind of push forward the state of witnessing for transparency ecosystems. So the registration link is shared there. Yeah, it's pretty lightweight and it is a free event. And there is a call for papers, which is open till the end of the week, as talk selection is already ongoing. I think if folks have already sent something in through the previous interest survey, yeah, those are definitely being looked at, and the schedule should be out in a week or two. But yeah, let me know if any questions, but that's it. Oh, sorry, you're mute, Hayden.
Thank you for the update. I guess maybe one question, is this going to be, are there going to be multiple concurrent tracks where, for example, you might have to choose between binary transparency or certificate transparency?
Yeah, no, great question. So it is a single track event. So Wednesdays, all kind of talks and lightning talks. And then on Thursday, again, single track talks. And then in the afternoon, the breakout session, which is sort of unscheduled, more like unconference style. So CT folks will go off into a room and binary transparency folks into one room and key transparency into another. And then on Friday, a few more lightning talks and also readouts from each of the rooms to just share updates. And then a witness breakout and some time, unscheduled time for the end of day Friday for folks who want to kind of hack on things or work together on projects. So yeah, that's something. Hope to share some more details soon.
Awesome. Thanks so much for the update, Tracy. OSSEU, Adrian, I assume you wrote this.
Yeah, I did. Great assumption. Yeah, so OpenSSF is going to be at OSSEU, and we're having our second booth. And this time around, we're really wanting to try and increase the community focus instead of just having staff standing there. And another idea we thought was really great, we had a few demos of different projects at the last event, and those just went really well. So unfortunately, we've had some changes in recent weeks, and so this kind of got pushed to the wayside as we're all dealing with those changes. So we only have 2 weeks to kind of get that schedule sorted out. But I wanted to reach out to Sigstore just because you all are one of our key projects, and I really wanted to put that opportunity out for any folks who are out in Vienna for the event. Get first dibs on project demos. We'll get a know before you go and a sign-up sheet shared as soon as possible. We're working on it right now. Again, apologies for the late notice and the scramble, but wanted to let you all know first.
Awesome. Thanks so much for the update. I'd also recommend posting on our Slack channel as well. I think you'll get a little more outreach there as well for folks who are coming.
Yeah, absolutely. Once we get those documents, then we'll do the reach out on Slack, and I think we have an email list as well. That's it. If there's no other questions, thank you.
Awesome. Thanks so much for the update. Awesome. So for our last part, if you're new to the community, we leave this time open if you'd like to introduce yourself. And if there are any other questions anybody has, we also leave this time open for those questions. All right, going once, going twice. All right, well, I hope everybody has a great couple of weeks. We'll reconvene in 2 weeks.